We have to decide what should be open and a public good. This is not from a business perspective, from a societal perspective, versus what should be closed. Should the tools to allow anyone to be creative, anyone to be educated, and other things like that be run by private companies? Probably not.
You're listening to Gradient Descent, a show about machine learning in the real world, and I'm your host, Lukas Biewald.
Emad Mostaque is the CEO and co-founder of Stability AI, which is one of the most exciting companies in the AI space right now. Before that, he was a hedge fund manager, and before that, he was an engineer and an analyst. This is a super fun interview, and I hope you enjoy it. All right, do you mind if I just go rapid fire questions?
Yeah, sure, go for it.
All right.
See you, Lukas.
Good to see you, Emad. All right, well, I think we need to start with defining, in your words, stability. I think everyone probably has heard of it, but everyone seems to have a slightly different impression of exactly what the company is and what it does. So let's hear from the source directly.
Yeah, so our official mission at Stability is to build the foundation to activate humanity's potential, with a motto of let's make people happier. Stability was basically set up in the belief that these new models that we have, these transformer-based models and similar, are essential for basically unlocking people's potential and some of those powerful tech that we've seen. And the belief that having them open source so people could build on them and use them was not only a great business model, but essential for, closing the digital divide and getting this out as widely as possible. So, we basically catalyzed the building of open source AI models, and then we take those models and we scale and customize them for customers. And that's what we do.
And I guess, how did you get started with this? Your background isn't originally in AI, or is it?
So I started my career in maths computer science at Oxford. I was an enterprise developer in my gap year. Then I did hedge fund managing for many years. So I was a huge AI and video game investor. But then I took a break when my son was diagnosed with autism, and I used AI to do drug discovery. So biomolecular pathway analysis of neurotransmitters and literature review to repurpose drugs to help ameliorate some of his symptoms while advising a bunch of hedge funds and others on governments, on AI and tech and geopolitics, etc. Going from that experience, that was about 12 years ago that I started that. It was super interesting. And then we saw that a lot of the technologies were evolving, but not until the last few years has it really taken off, obviously. So I went back to running a hedge fund after that, and it was fine. And then a couple of years ago, I was one of the kind of lead architects of Kayak, which was Collective Augmented Intelligence against COVID-19, which launched at Stanford in July of 2020, to take the world's COVID knowledge and then use AI to compress it down and make it useful. That's when I first really got exposed to, again, some of these new types of models. I was like, holy crap, this is huge. And they're getting good enough, fast enough, and soon cheap enough to go everywhere. And does it make sense that all this tech that's so amazingly powerful is going to be controlled by big companies and they believe their edge is that? Not really. Let's go away from that. So, I've got some AI experience and others, but mostly what I do is kind of see big pictures and big patterns and then put them together. A bit of mechanism design, as it were.
That's cool. I guess, I was wondering, you've had such a meteoric ascension in the, collective consciousness. I'm curious, has it happened exactly how you drew it up, or has it been kind of surprising? I guess when you started the company, what were you thinking? Because it wasn't even that long ago, right? And then how has it unfolded differently than what you expected?
Yeah, so we had the idea of Stability 3 years ago. The first thing my co-founder and I did was we took the Global X Prize for Learning, which is $15 million prize, the first app that could teach literacy and numeracy without internet. And that was by Elon Musk and Tony Robbins. And we were deploying tablets into refugee camps, saying, what happens if we use AI to make this more better and more powerful? We didn't use AI yet, but we just finished our RCTs showing literacy and numeracy in 13 months of education on 1 hour a day of being taught for refugees in camps.
Wow.
There'll be some big announcements about the AI-ification of that next year. But that was kind of like a fuzzy one. Then we kind of set up Stability properly 2 years ago to do the United Nations-backed AI work on COVID-19. Fell into a lot of bureaucracy and other things, but really kicked off properly literally a year ago. So I think nobody at that time would have expected that it would have gone like this. Originally, we helped support the communities at Luther and Lyon and others, and we were thinking This is a Web3 DAO of DAOs, like let's reward all the community members and get them together. But then after a month or so, we realized that commercial open source software of scale and service was the way. And while I was funding the entire open source art space, I thought it would be at least until next year that we got anywhere near the quality that we've seen now. So I think there's that pace of compression of knowledge and the ease of use and being able to get this on people's devices. That surprised me because I thought it would be another couple of years at least before we got there. I think that's been the main catalyst, right? Stable Diffusion being the first model that is good enough, fast enough, and cheap enough that anyone can run. Like it's a 2 gigabyte file from 100,000 gigabytes of data. That was the insane thing that I think's allowed it to go off massively.
And I guess, is it an accident that the name Stable Diffusion and Stability AI are connected like that?
Well, so this is an interesting thing. Like, what's the actual role of Stability? So we've got over 100 people. We got some amazing researchers, but our role is a catalyst in the community, right? So with Stable Diffusion, it built on the work of the Comphys lab at formerly University of Heidelberg, now LMU Munich, under Bjorn Omer. And so the two lead authors of Stable Diffusion were Patrick Esser at Runway ML and then Robin Ronbach, who works with us. And they came up with the name all themselves because, we provided computer infrastructure support and then obviously Robin themselves there. But we always try to give developers lots of flexibility, especially when working in these collaborations. It does get complicated there. We can discuss that a bit later. And they came up with it. I was like, yeah, I love that name. Go for it, But at the same time, there is this kind of inherent tension because a lot of people want us to manage the whole community, but that's not how open source works, right? The whole thing about open source is that there's lots of different things, even if you've got like Linux or Red Hat or something like that. And for models, it's also a bit different because the normal open source software, you have loads and loads of contributors, like hundreds, thousands. You don't really have that for models. It's like you can do the whole thing just with a team of 2 to 10 people. Or if you were like Lucid Rains, you do that all by yourself. Like he's one of the developers that we support. He just cranks out models every day. If you're a programmer that wants to feel bad, go and look at GitHub/Lucid Rains for productivity.
All right, I'll put a link in, but I don't want to look at it right now. I've been very unproductive over the last few years.
Yeah, make you feel terrible. Like, geez.
So I was curious about exactly like how that interaction works today with people building models. Like, what's your way of working with folks?
So yeah, I think that the best way is always kind of collaboration. So we have our supercomputer cluster here. It was 4,000 A100s originally. Now it's going much, much larger because I view that as a key unlock, and then the infrastructure support to make stuff usable there. We have the communities that we're spinning out into independent foundations like Eluther and others, where we provide employment and benefits and equity, etc. And then collaborations with academia, non-academia, independent researchers. I think the goal for the open source side of things is to put a lot more structure around that, so everyone knows when stuff is meant to be released, what happens if you've got ethical concerns and things like that. But again, really be a catalyst for the community. Some of the models you'll see released over the next period are entirely stability models. Some of them are combination models, but we want to make sure that these things are clearly defined because otherwise people get sad. And it's understandable as well, attribution should be given. One of the unique things that we have brought in, though, is that we're building an entire infrastructure to be able to scale and train these models. And if we do inference on any open source model, we actually put aside 10% of the revenue from that for the developers. So 5% goes into a community pool that will be activating in a month or two, where every developer affiliated with Stability can vote to allocate to the coolest research they can find. And half of it goes to the developers themselves, even if they don't work at Stability. So again, we're really trying to give back a bit to the community and recognize kind of the authors' things, like they can donate it or whatever from that angle, and trying to make it so it's clear how we interact with these because, we are the fastest providers of compute and support and technical support and input of anyone in the market because you could access supercompute before, but it was only really through these giant clusters with like 6 to 12 month processes for application, like, from Jules, which is pretty good, to Summit, which is much more bureaucratic, and some of the others. And that obviously doesn't keep pace with the pace of AI development now, which is literally exponential. This is why what happened is that a lot of academics basically had to leave to either their own startups, which, as you and I both know, CEOs is incredibly difficult, join a big tech company, which isn't so much of an option anymore, given the freeze that's going on. And that was it. And then, that doesn't fit with academia. So academia is one area that we're supporting in general. And again, I think compute is the key unlock there. But over time, it's going to be increasing the infrastructure side of things, and having standardized stuff. Like right now, not everyone uses excellent tools like weights and biases, for example, to track their runs. We would like to move to more and more open runs so you can actually see how they're doing, like Bloom did with, their updates, etc. So there's a lot of work to go, but we're trying to be as collaborative as possible.
Do you, so say I'm a researcher and I have like an interesting, area of work and I'm looking for infrastructure support. How do I apply to Stability, and how would you view my application? Like, what would you consider? How would you decide whether or not to fund it, and, how much to fund it?
So the way that we do it at the moment is that if you're an active member of any of the communities, from Harmonai for music to Luther for language models, Ion for images, you're most likely to get compute that way. And that can be from an A100 up to 500 A100s, depending on how good your thing is, particularly if you bring in members of that community as your team. So that's the primary way. Right now, we're setting up a grant-making portal. And, we're working with certain universities in that regard, but then also trying to figure out how do we do like large clouds of almost Google Colab on steroids to allow people to unlock things from day one. This fits in as well with the next stage of our program, which is that we funded like maybe a handful of PhDs so far who've been active members of the community. We're planning to fund 100 in the next year. And they will come with dedicated compute support for their labs and their projects as well. And there's an independent board being set up for deciding that, because again, one of the tensions is always going to be kind of our work versus, our business side versus the broader side. Like, why are we funding Open BioML to BioML? Because it's useful. There's no kind of business logic to it at the moment. But we want to keep that mix of, supporting the entire ecosystem so we have a nice place in it, and then focusing on some of the more business stuff, which is generative media at the moment. So I'd say for the moment, generative media, if there's anything interesting, you can just reach out on the communities, and we fund most things in there. The other stuff, we're building out the infrastructure, but just join those communities, join the Open BioML and other communities and contribute. And then that's the best interview of all, right? It's like you're more likely to help people who help your communities.
And then I guess like what's required of me, like say I'm someone with a new idea for generating like awesome music. Does that mean that I need to like contribute my model to the community after it's done training, or how does that, that work?
Like we encourage open source, but a large part of it is open access as well. Like we have incubator arm coming, a VC arm, and others for those who don't want to go open source, but we heavily encourage open source. I think not everything needs to be open source. What needs to be open source is the benchmark models. So it's like leave nobody behind, but the reality is that open source will always lag closed source. So like Midjourney just released version 4, which is amazing, right? And DALL-E 3 will come out soon, which will be even more amazing. Why? Because they can take open source basis and go ahead, or they can just do something different. So Midjourney version 4 was completely different, but version 3 with Stable Diffusion was a mixture of the two. So you will always get this iterating where open source will lag behind. We're just trying to make it so the lag is minimal and people start on that same basis. But for people who kind of come and use our cluster, the priority for the first cluster is open source. But we're going to have more clusters where they will also be for the companies that we're incubating, our own use and other things like that. Yeah.
How do you think about the sort of broad buckets? Like it sounds like you kind of do it by use case. Like, do you kind of think, I mean, it seems like you're kind of good at recognizing larger scale patterns. Like, do you have an opinion between the value of investing in infrastructure for audio generation, image generation, these large language models? Like, how do you even like approach that question of allocation?
So, right now, I would say from a business perspective, media is by far the most lucrative, and that can fund a lot of other stuff. So, Google and Meta have amazing research labs that they fund through advertising. And let's face it, we all hate advertising. Advertising is manipulative, particularly with these new models that become even more manipulative. The area that we focused on is the world's content. So audio, video, and others, those will all be in foundation models in the next 5 to 10 years, and we're focusing on that to fund everything else. So I think that's a reasonable model, because the Disneys and Paramounts and everyone of the world will eventually have to transform their entire archives. It's like the VHS to DVD uplift on steroids, perspective, because you know how difficult doing these models is.
Yeah.
So that's kind of a core focus on a business perspective. From an impact perspective, it's a lot more difficult. And this is also why, like, one of the things we've done now is, again, within a year, we built this giant cluster. So 4,100 isn't the largest private cluster, but on the public top 500 list, it's in the top 10, probably. Like Jules Booster with 3,744 is number 11. The fastest supercomputer in the UK, Cambridge One, is 640. The same with Narval in Canada, for example, and NASA's got about the same. So this is a chunky old beast. Like, the reality is that should be a public good eventually, and there is a national research cloud discussion led by kind of Stanford and a bunch of others that say this is needed for US universities. I think it's needed for international universities. And so hopefully we can figure out a way to transfer over there with this value function that you're discussing, because otherwise it turns into fiefdoms. So right now it's quite a centralized thing where we're just like, what can be most beneficial for the community and attracting assets to the community? And this was media for us. We're still doing the LM training, but large language models, I think, are less impactful because language was already 80% there, and we've gone to 90% there. Whereas a lot of this image stuff was like 10% there, and suddenly we've gone to 80 and now 90% there, you know? And so it's a lot more immediate for people. Because this brings us to the final bit, which is that the nature of these models is, and the data that they run on, is that they can do just about anything. So if you have them converging in terms of quality from different players and then an open source version, where's the value? The value can't be in models if they can do anything, right? The value has to be elsewhere. And so that's going to be very interesting to see, especially from, like I said, societal value versus business value.
But I guess what's interesting is, as far as I can tell, the main thing that you're doing, the thing that you're really passionate about, is democratizing access to creating and opening up these models. So I guess if the value isn't there in your mind, how do you think about creating a long-term sustainable business?
So it's basically, the value is in going into Hello Kitty as a business and transforming all their assets into interactive ones. It can be for the metaverse, it can be for new experiences, it can be for whatever. And then building tools to enable them to access their models and other people to access their models, piping it around the world. So our main play as a business is basically kind of content and helping big companies for that, and then helping everyone else through the software that we built. Like Dream Studio Lite is just a very basic piece of software. Dream Studio Pro, that's going to be released in late November, is a fully functional animation suite with storyboarding and fine-tuning capabilities and the ability to create your own models and other things like that. So again, being in that infrastructure layer and allowing the infrastructure to be usable is where we're at. Plus, of course, our APIs, which are industrial scale, and we're negotiating the cost down and down and down, because the data and how models are used, as many people on this call will know, is as useful as the models themselves, because then you can instruct them and you can guide them down. And, you know, the Carper team led by Lewis has done an exceptional job in releasing the first open source instruct model framework. And now we're training new models to be able to instruct them across modalities as well, based on some of this data. So I think that's where the sustainable edge is, a mixture of content and a mixture of experience. And the content, to give you an example, we have a deal with Eros in Bollywood in India, which is the Netflix of India, 200 million daily active users. All the Bollywood assets are going to be converted by us. And then all the music will pretty much sound the same. But, you know, it's like that data will eventually be converted. We're just doing it 5 years before anyone else otherwise would have.
And sorry, when you say converted into what?
So you take all the Bollywood music and then you have a text conditioned audio model that can generate any Bollywood music. And that doesn't need to be open source, you know, as a business thing. But then we can use the open source dance diffusion models and the new text conditioned ones we're working on to be the framework for that. So it's like you go and you do a MySQL database with someone and they load their data into it, right? And they're like, okay, well, I'm paying you to implement this because that's MySQL's model, PostgreSQL's models, or any of these other open source database providers or server providers. And that commercial open source software model is very well established. There's an extra wrinkle in this, in that they load their data into a model, but then converts it into a couple of gigabytes that they can then use for their internal processes and then external things. The extra wrinkle is that it's hard. It's hard to train these models. Even to fine-tune these models isn't that easy. We'll make it easier. And the pace of model development means that they have to retrain every so often as well. Until I think in image, you get to a steady state in 2 years. In video, probably 3 to 4 years. Audio is probably about 2 years as well for having a standard model in the space.
But I guess what are you doing for the Bollywood application today? Like, what's the conversion that's happening?
Oh, it's just like interest, right? Like Bollywood is just like basic. Well, we can't discuss it because we haven't announced it, but basically it's more basic TikTok type stuff and Snapchat type stuff and the things that you've seen with the use of Stable Diffusion right now, which is image based, quite static. But it's inevitable that entire audio and movies will be created using this technology, not zero shot, but in a pipeline of different things.
I
And so
see.
this is what we've seen with like you take EB Synth, Koei, and Stable Diffusion, and you can map a monster onto your face with the full kind of thing. That's the type of thing that we're thinking around this. So most of the Bollywood stuff is going to be used internally now to save costs on production. And then over the next few years, you will see it go from cost product savings to new revenue streams as people have new and interactive experiences across modalities.
So when you think about like your own internal allocation of resources, I guess humans, right? You have about 100 people, you said,
Yeah.
is that right? How do you break down like who works on the foundation models versus who works on the commercialization, or is that even the right way to think about what you're doing?
So we split it into two, basically, whereby the researchers who are open source researchers actually have in their contracts, they can open source anything they create, unless we specifically agree otherwise. And they're given a lot of independence and a lot of free reign to make mistakes. So, we can say we went overboard on compute, but that's what allowed us to experiment with different things, and we'll continue to ramp that up. Because a lot of researchers are constrained by compute and other resources. So it's like one training run or they're done, or they've only got like a 50% buffer or something like that. We thought that was the wrong way to have breakthroughs. Separate from that is the product and kind of deployment teams, like the customer solutions teams, because we don't want product to influence research too much. Like people are aligned in that they want to create a great business, so it could be self-sustaining. But when you have product influencing research, you get bad outcomes. So the product team kind of does its own thing. They work closely with the research team. And, they have discussions to influence at a high level it, but there's no forcing function,
I see.
So it's not like you have to have a model ready by this deadline in order for this product release. Because if you do that, you'll never have proper research. So that's kind of one of the ways that we split it out. And there's infrastructure that supports all of them.
Do you worry about someone else coming along and taking your open source models and then building their own like rival applications to yours?
I really hope that other people release more open source models. And that means that I don't have to, right?
Sure.
Because again, like our role is to help grow these communities and it's to provide the support for people doing that. So if someone wants to come along and create their own model, we can provide compute for them. Like there's a lot of different entities that we're providing compute for who people would see as competitors, because I think this whole market just grows massively. Like with Midjourney as an example on the outside, I gave a grant for the first A100s for the beta. And I said, when Stable Diffusion launched, they would be better than we are, and it's fantastic they are. Other people have had issues with quotas and other things. I've stepped in to try and help them, even though they might be viewed as competitors on the API, because again, I think the whole market will just grow massively. The key potential displacement point for us is basically another company coming and doing exactly what we do and supporting the community in this very strange way and being decentralized and having this division. But then it's like, why wouldn't you just stick with us? I think our replacement cost is quite high and the role of our company will change in the coming years. So now we're a catalyst to make sure and force people to go open as a forcing function. In a few years' time, there'll be more of a services company that is building Indian level models for the Indian and Filipinos and kind of other things and for the largest content providers. And then I hope over time we move into being an AI platform. So just making AI easy and accessible for everyone, because all the models will be pushed to the edge. Because I think they'll get smaller and smaller and smaller, and you're seeing custom silicon and like an iPhone and all these other architectures whereby a lot of these models just be a few hundred megabytes big, and you've got your own model, I've got my own model, and we're interacting with big models in the cloud. And I think that's a really interesting flip of the internet, and that's what we're aiming for. I don't think anyone I've ever seen is really doing the same. And if they are, they might as well join us, like we're cool, we're fine.
So you think, let me just understand this. So you think that, overall, it sounds like you think models in the cloud will get bigger and bigger, but there will be smaller versions of them for kind of ease of deployment and cost. Is that a fair summary?
I think that if you look at the chinchilla scaling paper, it basically, it sounds like more epochs of trading. It actually means better data. We need to segregate it. So I think data quality will become essential. I think the models will become relatively small, but then on the edge, they become even smaller. So it'll be kind of a hybridized experience, like when you use the neural filters in Photoshop. There's a point of processing in the cloud, and then there's a range of processing on your computer, right? Kind of this hybridized experience on Microsoft Flight Simulator will become quite commonplace for the running efficiently on these models. But I don't think that models will continue to scale. Like we'll see a trillion parameter model or something like that. But instead, I think kind of the almost MOE approach, where you have multiple models that are good at various things, will be key to this. Like right now, on the Stable Diffusion example, you're seeing people using Dream Booth, right, to create a GTA model, an Elden Ring model, or something like that. That's an optimal way rather than having potentially one model that can do everything. But we're not quite sure. And Dream Booth maybe isn't the best way to do it. Maybe it's Hyper Networks or something else. But I think different models for different things, and your own personal model, like a million models, is the better way than one model that can do everything, even though that's very attractive because it's like, yeah, let's just chuck it in. And we've seen these development of skills that you've scaled up. So I think scale is everything now. I think data quality will be everything, and model usage for instruct models will be everything. I think the value is going to shift there, even as compute becomes plentiful to allow for ridiculous scale.
So you predict like kind of a reverse of the current trends of people building bigger and bigger models. You actually think they're going to start to get smaller?
Well, I mean, look, Instruct GPT is at 1.3 billion parameters as performant as GPT-3, right? Similarly, kind of you look at T5 Flan and some of these other models that Google have released recently, the most performant models out there. Because like these are big neurons. You don't need all of that stuff. You know, similarly, like with the compute scarcity, relatively speaking, we just chucked a lot of random data into these things. But if you think of these models like a bit like the human brain, what's better, just a diet of like every piece of media out there or just the media that you need? You know, and what does that look like for these models? We don't know yet. You know, also it's moving so quickly that we haven't been able to keep up. Like a year ago, if I told you the image models would be like they are now, you'd be like, no way. Like even I can't believe it, right? And so this opens up big questions like, why is an image model? Why is Stable Diffusion 2 gigabytes and 890 million parameters, whereas you've got 175 billion parameters for GPT-3? You know, what's the amount of information they can convey? Does it make sense that text is so much bigger than image?
I don't know. I mean, it seems plausible that it's bigger than image. I mean, I guess my understanding was that these models, at least the language models, sort of generally get better on a broad set of benchmarks as the model size grows. But I mean, certainly other things matter.
No, they do. And again, this has been shown. But then, like I said, Chinchilla paper showed that they also get better as you train them more for a similar set of parameters. So a 67 billion parameter, 5 times trained model can outperform a 180 billion parameter model, effectively. But then you see other things, like with image models, it's the same. Google has a different type of model called Party, whereby they scaled it to 20 billion parameters, and it learned like language and things like that on the way. But like I said, Stable Diffusion being this performant at just a couple of gigabytes, 890 million parameters, makes you question what happens if we start optimizing the data? Because like we just chucked in a non-filtered data set, relatively speaking, like some of the bad stuff removed, just 2 billion images into that. What's the minimum number of images to have Stable Diffusion quality output? Is it 12 million? The model that Catherine, our lead generative coder, released in December of last year, CC12M, that was used for the original version of Midjourney and a lot of stuff, was only 12 million images. How many images do you need? How much text do you need? And then what effect does that have on the size of the models? And I think it's all scaling laws anymore. Even as, like I said, the compute becomes available now to scale infinitely. Like, geez, some of the clusters I see being built are insane.
Well, I guess it's sort of surprising. It's interesting. Your insight, maybe, as you put it earlier, was to, you know, that people really needed this massive compute to make it broadly available. But then it's kind of an interesting contrast to your current prediction that the models will become, you know, smaller and more specific. Like, does that make you think that, does that make you have any sort of plans to sort of change resource allocation or the kinds of compute that you want to sort of get ready for researchers?
Yeah, I think we basically don't need to infinitely scale compute anymore, right? It becomes then about data set acquisition, and we're building out a couple of dozen people data team to provide the right data for open source research. I think data quality is underestimated in terms of its importance right now for these models because people are like, scale is all you need, stack more layers, you know? And it was difficult to build a cluster even in the thousands of A100s just because there wasn't availability. But now you look at next year, I know of 320,000 H100 clusters that are being built. A H100 is probably about 3 times as performant as an A100. So that's like 60,000 A100s, like 15 times bigger than our cluster. It can train the GPT-3 probably in like 6 hours or something like that, one of these clusters. So compute is no longer really a bottleneck. But I think what we'll see again is that people will take the standardized models and they'll customize them down and then have a load of different models. And maybe there'll be 1 or 2 more big models. But I think it's not about big models anymore. It's about optimal models. And we don't know what an optimal foundation model is across a data training and, other architectural parameters yet, because we've been so constrained by compute and data and talent. And each of those is being unlocked right now.
That's really cool. I mean, what kinds of data sets are you thinking about building?
So we're talking to national governments about like national broadcaster data. You've got really interesting, highly structured things there that are high quality versus crawls of the internet. And these are public goods that should be available, right?
And sorry, what would that be? I'm not familiar with
Well,
with
so
that.
like you have PBS in the US, right?
Uh-huh.
Like their data should be available for model creation for academia, right?
Oh, I see. So you would just sort of acquire that data set or somehow get a license to make it available?
Exactly. To researchers initially, and then hopefully more people, because again, this is public.
Uh-huh.
It's paid for by the people, so it should be available to the people in various ways. Or
Sure.
even training a model on all the PBS radio station work, and they've
Uh-huh.
all got like transcripts. You could do it in various different ways. You can create synthetic data sets off that. So looking at some of these media data sets has been quite interesting to us, but then in other areas, it's about more than that. So like OpenBioML, we're doing the usual protein folding and some DNA stuff and supporting things there. But in BioML, there's just a lack of quality data. So like one of the things we'll probably do soon, we're just deciding on this, is a prize to basically identify what data sets should be built and then bringing in external funders to help build those data sets. So protein folding was quite good because there was a great data set and there was an objective function of quality. And so people could build around that. So you have OpenFold, you have LibreFold that we're doing and other things to make that more and more efficient. Other things in BioML don't have that. Within the language thing, we're doing the PILE version 2. So the PILE version 1 from Elutha was very widely used. And the PILE version 2 is much bigger. With images, we had Lion. So Lion were the first largest image data set was 100 million images, YFCC 100M, which was the Flickr data set from 2013. Lion did Lion 400M, which is 400 million images, text pairs, last year. And that was used by Google and Meta and a whole bunch of others in their models. That's how good it was, because Google and Meta and others are actually constrained about using their user data because of FCC regulations and other things, weirdly enough. Now they've done Lion 5B, which is 5 billion images parameters, actually 5.8, and they're going to go even bigger. So it's creating these big open source data sets, replacing a lot of the scraped lower quality stuff with some of this public sector data and encouraging others to contribute to it, and then building great data sets for every modality so that everyone, again, is on the same page. And I think we've got to the point now where the communities that we support and our own internal teams are building better data sets in some cases than even private companies have access to.
Yeah. I think one of the disconnects that we see talking to a lot of researchers and talking to a lot of, companies, of course, there's a lot of overlap in applications and deep learning is incredibly practical in lots of ways. But I think a lot of companies are kind of looking for more research around time series and kind of structured data. Do you think about sort of investing in that realm at all?
So we've had some approaches for kind of time series analysis and things like that. I'm not sure these foundation models are the best things for that, to be honest, because I view them more like principle-based analysis in the brain. Like, with my son with his autism ASD, the main thing about that is there's typically a GABA glutamate imbalance. So GABA calms you down like when you pop a Valium, and glutamate excites you. So there's too much noise. And then once you calm down that noise, you do repetitive trial teaching so that you can rebuild things like words. Because if there's too much noise, you can't learn the connections between concepts and words. Like a cup is a world cup your hands, all the different kind of cup meanings. And then you rebuild that. These models are the same, and they can figure out the latent spaces or hidden meanings of connections between different labeled data sets. And with time series and things like that, I'm not sure this is the appropriate thing for that. Again, we're funding a little bit of research in that area, but I think that a lot more of the classical ML things are a lot better to do that, because you typically don't do out of sample kind of stuff there. The kind of like looking at the hedge fund stuff, you are typically inferencing and extrapolating versus trying to do first principles analysis of like what is a Van Gogh painting mixed with a Banksy painting and these types of things. But again, I think 80% of research now in AI, I think this is in the AI index report that was released by Stanford, is in foundation models. So,
Wow.
we're one area of funding of this, and again, quite focused around media and language. There's just a whole world of funding around this area. So if it is useful for time series, I'm sure we'll find out sooner rather than later. Or maybe we won't. Maybe they'll just take it, run a hedge fund, and be like, ha ha ha, get all the money.
Do you have an opinion on kind of other architectures? Are you seeing anything? I sort of feel like it's amazing the convergence around transformers in so many different applications. Do you see any signs of that changing? Or
potentially there are some promising things that I've kind of seen. You don't necessarily need attention. As some recent papers kind of have shown. I'm trying to remember which ones. And there's some attention-free transformer stuff being done with kind of one of the projects that we're supporting around RWKV on the language model side. But I think transformers are probably going to be the primary way of things for the next couple of years, at least, just because they've got momentum, they have talent. And again, the commonality of architectures around this, you're like, hey, let's just chuck it at this or that or that. And you're like, it works. And we're just scratching the surface. Like, for those who don't know, kind of with images, last year we had kind of, the big breakthrough in January and February by like Ryan Murdoch and Catherine Krause and some others was to take the open source clip model that OpenAI released, a generative model, VQGAN, and kind of that was Robin Rombach who kind of did that one with his team at Conviz. And having a generative model and a model that takes image to text and bouncing them back and forth across each other to guide the output to get more and more coherent stuff. In December, Catherine postulated clip conditioning would be the best way, taking a clip model, the language model, and a diffusion generative model and combining them together, and somehow it learned the stuff. Then Google, with the Imogen team, took a language model T5XXL that was a pure language model and mixed it together with a diffusion model, and somehow it learned how to write images, and it got even better. And everyone was like, wait, what? Like, we still don't exactly know how these things work, to be honest, and the potential of extending these. So I think transformers have a long way to go. But again, there's a paper that I don't know if you saw it, the number of papers on Archive. It's literally an exponential with a 24-month doubling on ML.
Yeah.
Like, it's just going crazy everywhere. Like, who knows what people are going to come up with. And the interest in this area compared to basically the rest of the global economy means there'll be more and more resources just deployed towards this, because finally actually showing usefulness. It's just where that usefulness and value will lie, nobody really knows. But until then, just take some data and chuck it into the H100s, stir it up and see what pops out the other side.
It seems a little surprising that you have this amazing company that does all this kind of cutting edge, research in ML and model generation, and the killer application, or the first really big application, is sort of generating media. I never would have kind of thought that a priori. Do you have other areas that you sort of expect to take off, or that you're looking into?
I think you shouldn't underestimate media. Like, the easiest way for us to communicate is doing what we're doing now. We're having a chat with our words, right? The next hardest is that we're writing each other emails or chats, and to write a really good one is very hard, right? Like, I made this message long because I could not spare the effort to make it shorter, I think someone once said. Right. The hardest thing for us to do is communicate visually as a species. So this is why artists are great, PowerPoints, we've all been there and stuck there. With a combination of a language model, a vision model, and a image generation model and a code model, you don't need PowerPoint anymore. You can just speak and it'll create beautiful slides every time, right? Like, with art and visual communication, anyone now, my mum could create memes and send it to me about why I don't call her enough in an instant, which she does. Like, humanity can finally communicate both through text now with these language models. And you've seen how things like copy.ai and Pseudo-Write and Jasper have made that easier, and now visually as well. And the next step will be 3D. Like, that's a change in the way humanity communicates, which is a huge deal. So again, language was valuable, but it was really getting there. You already had help, like your Gmail suggesting you should tell him to bugger off in your replies or whatever, right? Now it's kind of the next step there, which is image, and then 3D and things like that will follow. And that's valuable because, again, we have to look at where the money is. The previous iteration of the web was all about AI being used to target you ads. You know, now it's about something else where you're moving from maybe consumption to creation. So my focus has been in this area as the main driver there. But in terms of impact and global stuff, the ability to switch between structured and unstructured data dynamically at a human level because it understands the principles, when combined with like retrieval augmentation and other things to check for factual accuracy, is such a huge deal because it means that you can write reports, you can do legal stuff, you can get rid of bureaucracy. You know, it's the first technology that enables so many things because it's so general that we're not sure where the value will be. But I do see the value in anyone being able to express themselves and communicate better. And so I think that we shouldn't underestimate that particular aspect of things.
I guess I also wanted to ask you, and you've talked about this a fair amount, but I'd love to hear directly. You know, you made this kind of decision to make all your models really open in kind of contrast to what OpenAI and others were doing, which I think people got really excited about because it sort of felt like, I think with some of the earlier models, there were kind of these gatekeepers, like no one could really access them. You know, some models like really like no one except people at the company could access. But I do think that I remember the reason that some of these models didn't get opened up was sort of or said to be kind of ethical concerns at the time. Do you think that there's any kind of merit to that argument? Do you think about that at all? Like kind of models being used to like trick people or spam people or things like that?
Well, I think it's a valid point of view. I mean, basically the logic there is similar to the logic of orthodox and ultra-orthodox religions, which say anything that leads to a sin in itself is sinful. And so just in case. But it's understandable because these models are so powerful that you move from a risk minimization framework where you've got an expected utility. What's the positives? What's the negatives? And you try to figure that out roughly, right? To a regret minimax. If I release this model and something goes wrong, my company could get blown up. I minimize my maximum regret. And we don't know what it can be used for because it can be used for anything. However, I think the last few years have shown this. GPT-2, too powerful to release. GPT-Neo and the other things come along. The world hasn't ended, you know? Stable Diffusion has been in the hands of 4chan now for 10 weeks. And all they've basically created is like Cronenbergs that have given themselves nightmares. Like, it's not great at creating these things. The bad guys already have the technology, you know? The nation states, Russia has tens of thousands of A100s, right? And the people can run them. So they can build it. And we don't have immunity to this new alien technology being out there. Because ultimately we live in a society that regulates against stuff. So if you are creating bad things, you'll be regulated against, you know? If you are using it for bad purposes, again, the means of distribution are the social networks that have rules and regulations in place. Because what you're really trying to regulate is not content. As bad content is bad, you're trying to regulate behavior, and then it's about who's allowed within these communities and not allowed within these communities. So I think a lot of this stuff gets mixed up. And then the other aspect of it is this AI safety alignment issue, right? Of the technology killing us all. I will say quite clearly, I think that GPT-4, when it comes, will be more dangerous than GPT-4chan, you know? Because a model like GPT-4chan that was trained by Yannick on 4chan that produces just puerile rubbish isn't really going to go anywhere. It's just going to produce puerile rubbish a bit easier. Whereas a GPT-4, which God knows what it'll be, but I'm sure they'll do an amazing piece of work. The large models that they're creating now are getting to human level, and we don't know how exactly they work. And they're being created by unregulated entities with these models that are powerful as any technology out there. Small models are not the issue, being widely used and the community regulating it. Big models are the issue. And we should have more oversight on that just in case some of this AI alignment stuff turns out to be correct and these things are dangerous, which I think they probably are.
But I guess you believe that these small models are also very powerful. So why would the regulations be different for the size of the model?
Oh, because they're not open, right? So when they're open, everyone can check it. So right now, everyone's poking around and saying, oh, there's artists Are they going to be compensated on Lion and this and that? And we're like, cool, let's have that discussion in the open space. What's the best mechanism to do this? We've got a $200,000 deepfake detection prize coming up, where we'll give it to the best implementation of open source deepfake detection. It's available for everyone. Everyone can be a part of it. Whereas the big guys, there is no control. Like, again, the example I gave a bit earlier, imagine that Apple or Amazon or Google or someone integrated emotional text-to-speech into their models, right? So Siri suddenly has a very alluring her type voice and whispers to you that you should be buying stuff. You'll probably buy it more. Is that going to be regulated? It's not currently, and it won't be in time. Whereas putting these models out into the open will get people to think about, actually, that's something that probably should be regulated. And if something is regulated, that is fine, because it's a democratic process. Whereas companies using this technology to manipulate us, literally, because that's the advertising model, I don't think is appropriate. You know? And again, it's not just Western influence and deepfakes and elections and stuff like that, because when you look at that, there is a herd immunity thing, not COVID type thing. Again, there's lots of work in COVID. People understand this technology will mean that people will be more discerning over curated outputs, and then it will be a mixture of this detection technology. And then, for example, we're part of content-authenticity.org, where all our future models will have EXIF files, well, special metadata files showing that they are generated by default in the package. Now, will people choose to use them or not? They may choose not to use them, in which case they won't have a tick next to them, right? So there are all sorts of ways to do this, but the reality is that, again, this is a complex debate that cannot be decided basically in San Francisco. It's something that is important because this technology is inevitably around the world. And if you actually poke people, you say, okay, so you don't want this technology to be used by Indians? They're like, well, of course we do. When it's safe to. Who decides that? We do. So they're not smart enough to decide it? No, they need to be educated. And then it gets really bad, right? Like, but again, I think it's understandable because it's scary and cool and scary all at the same time.
Are there any applications currently of the models that you've built that make you uncomfortable that you would like to try to prevent?
So like there was an example of a Dream Booth model being trained on a specific artist style. And so it was like cute Teen Titans type artist. And it was announced and released as that artist's model. Mm-hmm. But they had nothing to do with it. And I felt uncomfortable with that because I don't think that styles can be copyrighted. But it was like almost this co-opting of the name of that artist to do this. Like eventually it got changed after discussion. There was a piece about that. Like we're entering some of these gray areas where we have to decide these things. And we have to figure out things like attribution mechanisms and other stuff. You know, like Deepface Lab has existed for years now. It has 35,000 GitHub stars for doing deepfakes at high quality. Maybe with this technology you can use it a bit easier, but that's the inevitable pace of it. I think we have to figure out some of these things around attribution, around kind of, you know, giving back, and around making sure that people's things are used appropriately, right? Because like in general with attribution and copyright and things like this, these models do not create replicas when they're doing the training. If you look at how a diffusion model works in particular, and they just learn principles. So again, styles cannot be copyrighted. It's very difficult to do that. But when it comes down to the individual basis, I'm still struggling a bit with how do we prevent that from happening and people co-opting other people's things other than in a court of law? Is there any automated system? Because you have the ethical, moral, and legal, and community typically enforces kind of moral. Ethical is a more individual thing, and we have the Creative Open and Rebel license for that, and legal is obviously a whole other thing. We don't want things to get down to legal. It's like, how can you encourage community norms? I'd say that's probably the primary one here that just made me a bit uneasy.
I see. Interesting. Do you do any kind of like in your APIs that you offer, do you like put restrictions in there that you don't have in sort of the open source models used just directly?
Not 100%. So again, it's regional specific and it's general and it's very kind of safe for work, shall we say, because again, it's a private implementation of an open API. Uh-huh. Even with the models, like Stable Diffusion shipped with a safety filter that's primarily kind of pornographic nudity based, just in case you got an output that you didn't like. Like the new versions of it will be more accurate to reflecting what you want. And again, trained on potentially safer data sets, etc. But there's obviously a different bar for a private implementation. Again, our basic thing is that these models should be released open as benchmark models with safety around it. So like I said, there was a safety filter. Actually, if you trip the safety filter in the open source version, it shows you a picture of Rick Astley, and you can adjust the safety filter or you can turn it off. Mm-hmm. And then there's an ethical use license. Any other suggestions for improvements to that? We'd love to know. And again, I expect that this technology will proliferate because we catalyzed it. There was the contributions from kind of Patrick at Runway, from LMU, Confi's team, and others. And it was led by those two developers. There'll be a variety of models of different types being created by a variety of entities. And some will be safe for work, some will be not safe for work. But I think we should try and figure out some standardization and norms around this as this technology starts to proliferate. But again, that should be a communal process.
You keep mentioning these communal processes, and I'm curious, what happens when the community has like deep disagreement with itself? I imagine that happens all the time. Like, how do you kind of resolve a community where people might have really different sense of what's moral and sort of draw lines in different places? Has that happened yet in your community? And how do you expect to?
100%. It happened, after the wake of the Stable Diffusion release, and people like this can be used or not safe for work, and we don't feel comfortable with that and supporting that internally with instability. And so we had discussion as a team, and we decided not to release any more not safe for work models as stability itself, Now, some people weren't happy with that. Most people were fine with that, but that was kind of easier because it was a team decision. On a community basis, that comes down to governance structures, So right now, one of the things we're doing is we're looking at Luther AI, and we want to spin that out into an independent community because it's got lots of different entities and it's got lots of different points of view. What is the appropriate governance structure with it? Is it Linux Foundation, PyTorch? There's a lot of OSS kind of things. It's a bit different because these technologies are not like what can you do with Linux really, right?
Yeah, exactly.
Whereas what can you do with like the most advanced language model in the world? It's a lot more complicated and needs a lot more voices there. And that's why we're taking some time just trying to say, this is a governance structure on day one, but we need to make it adaptive because we're not sure exactly where this stuff will go. Right now, we as Stability have a lot of control over GPU access and a lot of this stuff. It's kind of the spice. That shouldn't be the case going forward because no one entity, whether it's us, OpenAI, DeepMind, or another, should have control over this technology that's a common good. And so again, we want to be contributors to like an independent not-for-profit, as it were, as opposed to controlling this technology, and then have our part in supporting and boosting it being open source. I think eventually what will happen is people really disagree, they'll just fork. And so we've seen that in various communities, just fork it, right? It's the beauty of open source.
Yeah.
And you can go and do your own thing.
Although I imagine it might be easier to fork a model because one or two people could kind of like take it in a different direction.
Yeah, I mean, like you can fine tune models, you can fork models. I think the key thing here is benchmark model. That's a lot of compute up front, right? And then fine tuning and running it's relatively little compute. This is the opposite of kind of the current paradigm of Google or Facebook, which is relatively little compute to get it into database structure. And most of the compute is done in time of inference, right? So you can take a Stable Diffusion model right now, you can train it on your face with 10 images or 100 images, and then boom, you've got your own like Lukas model that can put Lukas in anything, right? That's a flipping of the entire paradigm. But that isn't a forking of the community. A community fork will be, disagreements over safe for work or not safe for work as the data sets, crawled or licensed or things like that. And I imagine we will see different communities around this, around some of these key questions.
Although I guess what's tricky maybe about this and a little different than other communities is you're kind of holding this very valuable resource in terms of compute. So at the end of the day, you will have to kind of arbitrate more aggressively maybe. Like for sure, anyone could easily fork stuff, but then they would have to kind of potentially ask you to get the compute resources to really, like make a meaningful fork, right?
Yeah, 100%. So right now we have a lot of control because we're the fastest supplier of compute. But part of what we're trying to do as we spin these off independently is make it so they can access their own compute and also stimulate some of these national clusters to be more open. It doesn't take 6 to 12 months to get A100 or H100 access anymore. So I think, again, it deserves to be a bit more diverse, to have multiple parties at the table as opposed to centralized. And this is a deliberate action by us to move towards more and more distributed and decentralization, both from kind of an ethical and moral perspective, but then also, like I said, from a business perspective, it works for us as well. Because if we're considered to be in control of everything, like we don't know what's going to happen there. And it's really a lot of effort to coordinate an entire community that likely, won't be positive. because it's going to be a lot if this goes to 100 million, a billion people as we expect. Coordinating all of those. Instead, it should be an independent entity doing that where all the voices can be heard. And we've got our own part to play within that. So we go from being the main provider of compute to being a provider of compute, to hopefully all the compute is provided by the world effectively to do this properly, because it is a public good. And that's good for us because it saves our costs, right? The open source models get created without cost to us.
I guess, so you imagine a world where a huge fraction of the world's population is training models. Did I understand that right?
No. So I think everyone in the world will use these models. I reckon there will be like thousands of developers creating these models to certain standards established by the various communities and others in interrelation with each other. So you will have standard benchmark models like, Red Hat version 7 or something like that, or Ubuntu 20. Like there will be regular releases of these models. It will be independent. The countries and others will provide the compute for it. We'll be one of the voices at the table doing our little bit. And then people will build on those benchmark models and fine tune them for themselves. So, on the Apple architecture, like I said, there's a neural engine that's not really used. Others are having these same kind of foundation model engines that are coming through. So I think in 5 to 10 years, you'll have AI at the edge, AI in the cloud, and the hybrid interaction of those two will be super powerful across modalities. And this is also one reason why we are fully multimodal. If people are like, why don't you just focus on image? Because you don't know where the learnings come from or the value across all of these. So it makes sense for us to be that layer one infrastructure layer there to get things going and then have a business model and scaling this.
Yeah, that makes sense. That makes total sense. I wanted to make sure I asked you about education. I mean, that kind of comes up every time we talk. It comes up in every interview you do. It's obviously something that you're super passionate about. How does education kind of fit into stability?
So a large part of stability for my own personal focus is around the rights of children, because a lot of ethics is complex and things like that, but we all agree that children don't have agency and so they have rights. I'm not talking about effective altruism a million years from now. I'm talking about kids right now today. And I was like, if I could go to the future and bring back technology to make kids' lives better, what would I do? I allow them to create any image, right? And use these tools. I allow them to do code, the type of stuff Amjad Replit does, I would allow them to communicate and be educated in healthcare. So with the education thing, it was like first proving that an app and a tablet could actually make a difference, which we've done now through the RCTs. Now it's about bringing the world together and saying, what's the best darn experience we can have to teach these kids? Because it doesn't make sense that we teach arithmetic in a different way across every single country. And we don't know what the best way to teach linear algebra is. No. But then having an AI model that teaches the kids and learns from the kids at scale, because you do entire countries at once, is the best data in the world for creating national level models. So if you want to create a Malawian model, you need to capture the Malawian culture and all the context. And if you're ever trained by little Malawian kids, that's a national level resource. So this is what I discussed in the upper part of the country. Like, we're not feeding AI models the right things. We're feeding them a mishmash of stuff. But if we actually intentionally create data that teaches them to learn, that's going to be the best models out there. And similarly, like I said, the discussion that we've had about AI models going to the edge, having control over the hardware, software, and deployment means that we can standardize these tablets to be little AI machines, which will be amazing because they'll have a richer experience than anyone else. And I personally think, I don't know if you've got kids, Lukas, but 13 months, 1 hour a day, you learn literacy and numeracy is good for any kid anywhere in the world. In a refugee camp where people earn a few bucks a day at best, like I think Malawi's like $5 to $10 a month, it's crazy, especially when you've got one teacher per 400 kids. How else are you going to educate them other than with this technology? How else are you going to do it other than creating an open source standard that's scalable and working with the World Bank and others to scale it? So I think this technology has a huge role to play in education. I think that incorporating into the West will be incredibly difficult and an uphill battle. Taking it with ROI is largest in terms of emerging markets and places like that is going to be the best. And then we'll create a system that's better for everyone. Because again, we have to decide what should be open and a public good. This is not from a business perspective, from a societal perspective, versus what should be closed.
Yeah.
Should the tools to allow anyone to be creative, anyone to be educated, and other things like that be run by private companies? Probably not. They should be a public good. Should they be United Nations and other bureaucratic hellholes? Probably not. So with this technology coming right now, there's a little window where we can create better, more adaptive systems and bring them to the people where it can have the most value. And that's what stability is focused on, because then you can build a real infrastructure for the next generation.
And just to be like concrete about this, you're imagining making like a tablet that has like an AI teacher that's literally like talking to students and teaching them things like linear algebra. Is that?
Yep, I want to call it one AI per child, but others are against that. But that's the concept. You have an AI that helps you, because one is AI, but information classification, right? So what's that information that can help that kid be in Malawi or Brooklyn to the next part of their journey, right? And then having a standardized architecture for that, so you can take what works in Malawi and apply it to Ethiopia, or apply it to Benin, apply it to anywhere, makes sense. And the output data of that is customized data sets that are ideal for local language models and local image models and local video models if you execute correctly. So this is why, like, I think, we are not OpenAI or DeepMind. We don't train giant models. The entire focus is AI that's accessible for everyone. It's emerging markets and creativity. Those are our two kind of focuses. Again, like, I don't really care about AGI except for it not killing us. I don't want to create a generalized intelligence. I want to create specific intelligences that are widely available, so we close the digital divide and makes people's lives better. That's the key focus and lodestar of what we do.
That totally resonates with me, but don't you feel like the trends lately have been creating better specific intelligences through creating better general intelligences? Like, I've been kind of watching, the last 20 years of machine learning seems like, sort of more and more kind of general purpose things that are then fine tuned on specific applications. Do you sort of expect that trend to change?
Well, I think it's an arc, right? So it was scaling is all you need and more layers, and now it's better data sets, right? And so as you kind of have this adaptation, I think the intelligence goes to the edge. I think instruct and the combination of reinforcement learning and deep learning is the next big trend that we're seeing start to accelerate. And that's why we've got Copper AI as our kind of representative contrastive learning lab. And so I think it'll be loads of models, because these big models were there, but they weren't really used, right? Now they're being used. So Stable Diffusion is being used it's being used by millions of people each day. As it gets better and as people release more models, this technology will be used by more and more people, be it private or public. And so I think that then it becomes about inference and, cost. Because if you've got a model that's open source and 80% is good as a closed model, because open source models will always be worse than closed source models, because you can always just take it and make it closed and train it on better data, then that creates a different paradigm. And again, I think it was this breakthrough point whereby stack more layers became less effective as you kind of went up. Now it's a case of make the layers more effective, as it were, and figure out how do we optimize these models. If we can start doing A/B tests and training 10 of them at once, where are the key optimization points here? And I think that the optimization points will be a model that's used by 1 million people versus a model that's used by an internal team. 1 million people will always win, because people will figure out all sorts of tricks, like dream booth training. So that's where you take a few pictures of yourselves and it's kind of fine tuning for the image model. That was 48 gigabytes when it first came out of VRAM requirement. After 3 weeks, it was 8 gigabytes by the community building on it. And having that and having hundreds and hundreds of developers hacking away at these things and figuring out how to put them into processes as opposed to zero shot. These won't be the best for zero shot, but they will be more useful because they're in pipelines. And I think that we've shown that with Stable Diffusion versus, other image things, which are within their thing. But now we just have to upgrade the models again.
Well, all right. I have one more question that I didn't actually prepare. I'm kind of curious if you have thoughts on, which is that, you've talked about your autistic son a few times, and I actually have a little sister that's autistic, and autism has come up in many of these interviews that I've done, often like autistic family members. I'm curious, do you see any kind of connection between autism and machine learning, or?
100%. I mean, this is why I really love transformer-based architecture, because what I did with my son in terms of repurposing drugs for him, and we'll do a full formal thing about this in the next year or two, where we'll share all the learnings, it's about reducing the noise and getting him to pay attention by reducing the imbalance. So there's too much glutamate making him excited, so not enough GABA calming him down. And then having things like applied behavioral analysis, where he does rapid kind of iterations to learn that a cup means things and various things, with a variable reward schedule where he gets rewarded at random, so he's more motivated to rebuild these things. It's similar for a stroke victim and other things, but again, you look at what these machine models do with transformer-based architectures. Attention is all you need. They pay attention to the important parts. And that interconnection of creating latent spaces within layers of meaning is exactly the same almost. Well, it's not the same, but the same principle as what we do for rebuilding kind of the language capabilities of our kids. And so this is one of the things that really drew it to me. And I was like, I kind of get that. Like I have Asperger's myself, so I've had to rebuild and refigure out a lot of stuff. And so principle-based approaches. So that's why I was like, it's almost like type 1 versus type 2 thinking. Retrieval versus instinct. Combination of those is the most powerful combination we've ever had as humanity. And again, I think that it'll really be able to help with this. The other aspect of it is personalized medicine and education and other stuff. We don't have enough teachers. We don't have enough doctors. These technologies are now reaching human level in very narrow fields. What if we could put this on tablets out there? One AI per child doesn't just mean like something. It's literally an AI that can help them in everything if they've got special needs or if they're neurotypical or anything like that, and personalize this stuff for them, because our education system treats everyone like a number. It's like ergodic versus the non-ergodicity of humans. Like toss 1,000 coins at once, the same as tossing one coin 1,000 times. And the reality is we are all unique, but we didn't have the tools to personalize until now. And this is the first technology that could do that. So in doing that, we can figure out systematic diseases and conditions like autism, like COVID and others. This is why I focused on COVID. This was a multi-systemic disease that modern science wouldn't be able to deal with. Like, why do you have kind of massive kind of ferritin levels and other things in the blood? Is it serotonin syndrome? Is it this? Was it that? The first principles analysis of COVID is even still lacking today. Thankfully, we found treatment. And again, models are on science, but information isn't getting to where it's needed in a personalized basis. And again, we can build systems for that. But AI models are only one part of that. There's more classical open source AI for the rest of it. So yeah, I think there are kind of parallels to this. And of course, being in our industry, it is very, very prevalent, right? It's like a double-edged sword.
Well, I'm curious, do you think your Asperger's has given you some advantages in building this really unique company?
Yeah, no, 100%. Like my real skill is mechanism design. I know how to convince governments and multilaterals and others. Like Stability has huge international support because I've positioned it just right at the right time. And my Asperger's and ADHD typically balance each other out, I like to say. So you've got to focus on what you're good at, and that's what I'm good at. So that's my job here, to absorb the hate and to also do the big things while letting the real heroes, who are the developers, and the community kind of get on with things. Also, it allows me to have a different perspective in that most companies would try to control this, but really we are just trying to capitalize it and get it out there. Because I think, again, from a mechanism design perspective and morally, that is the right thing to do.
Interesting. Well, we always end with 2 questions. I want to make sure I get them in. So the second to last is pretty open-ended, but I usually ask, what's a topic in machine learning that you think is underrated? You've mentioned a whole bunch, but is there anything else that you think is sort of deserving of more study than it gets right now?
Machine learning. I think it's really data, to be honest. It's like, you can say classical AI was largely data science, but the role in data in these models is vastly just not looked at all. Like, I think that you can do 10, 100 times less data for better outcomes on these models once we kind of really look at it and how the data impacts the latents and some of these other stuff. And so, like I said, we're building a team for that. And other people have been doing data cleaning, but I don't think that's enough. I think we'll see some remarkable things advance in that aspect.
It's so funny because my last company that I ran for 10 years was data collection. And we always found actually data cleaning was the most important thing that anyone could do to make their models better. But we could never convince people to do as much data cleaning as we thought they should.
So everyone's totally like, stack more. It's cooler to stack more layers, right?
Yeah.
I think, it's data cleaning, data structure. There's a whole bunch in there, I think.
And then the last question that we always ask is, what's a kind of hard part about taking a model and actually turning it into a product? And you've obviously just recently created some products built on top of these big models. I'm curious, outside of the training of the model, what's been maybe some unexpected challenges in making the whole product work cohesively?
So we have Dream Studio Lite and Dream Studio Pro coming up very soon. I think probably the key challenge is just getting it responsive enough to have really that user experience that is seamless. Like, we've gone sub 1 second now on inference, but that was very difficult to do. Like, we had to do a lot of optimization there. Because again, these are, even if this is relatively small, it's still a large model, right? And the second part, I think, is around some of the fine tuning and creating custom models. That's a pretty different take on things. And I think there's a lot of work that's been going on into like, where do we actually store the models and keep them, and the user data aspects of them becomes a very curious thing. But I think the most important thing is just having the snappy consumer feedback loops for these large models that will maintain, especially because we're doing animation, which people don't want to wait around for. They either wait a long time or they don't want to wait at all. They're like, why isn't it real time? Because normally this would take like 3 weeks, you know?
That does sound challenging.
Yeah.
Well, thank you so much. I really appreciate it. That was a fun interview.
No problems, Lukas. Cheers, buddy.
If you're enjoying these interviews and you want to learn more, please click on the link to the show notes in the description, where you can find links to all the papers that are mentioned, supplemental material, and a transcription that we worked really hard to produce. So check it out.